Alrighty, so we have our game here. And yeah, I guess I need to kill these. So we have the beginning created, we have the end created. Now we need to make the game screen. So my game's going to have like a border that it can't touch. If it touches the border, it dies. So what I'm going to do here is I'm going to go to the content. This is going to be the background, and this is where we're going to put everything, is on this game frame right here. So these are, I've already created these in Photoshop, but these are the sides of the border and the top and the bottom. So I'm just going to click and drag these out. Maybe. Or not. It's locked. Oh. Probably help if I unhid that. There we go. Okay, so I'm going to kind of put that in the middle.
Does it matter which part our background is on?
No, it doesn't matter what layer really. Unless, I mean, obviously it needs to be on a lower level because I'm going to put my characters and stuff here so they're on top of it. But that's really not a big deal because once they hit it, they're going to die. So yeah, kind of a long way of saying no, it really doesn't matter what layer they're on. All right, so here's the right side. Kind of line that up, throw on the left side. Where the crap is the bottom? There it is. So all the stuff that needs to be detected with a hit detection needs to be created into a movie clip. So I'm going to have my character in the middle moving around depending on the accelerometer, and then if he hits any of these sides, he dies. And it's going to go to the end screen. So I got to convert these all to movie clips. So F8, call it top, then just make sure movie clip is selected right here. And I'm just going to go one by one. Okay, and then now that they're movie clips, they need to have instance names so I can call them in the code and do stuff with them. So I'll call that RS for right side. Call this bot for bottom. Call that one left. Let's keep it the same as the other. LS for left side. And then top for the top. Save that out. And also, I recommended if you're just following along and you just want to get it to work and then worry about all the, tidying up the stuff later, you can just draw squares over here. So I could draw a square once I've drawn it. Guess it's kind of in the same way, but I could just draw a square here and then convert that to a movie clip. Double click, make sure the fill and everything is selected. F8, and then I could call that the left side or whatever. That's just kind of a placeholder. You can draw that to be your border, your temporary border. Just to get it to work. Once it's working, then you can go in there and replace it with something that's a little more video game-y. So we got the border defined. Now I need a character in here. So I'll hop out to the interwebs to grab something. Oh, yeah, Pac-Man all the way. So I need to make him a PNG. Ooh, are any of these PNGs actually? Ooh. Yeah, why not? Pac-Man's kind of cool. Even though this isn't Pac-Man, but it kind of is. Sure, that works. So I will save the image, throw it in my game folder. It's probably breaking all kinds of copyright laws, but oh well. It's all good. For now. Not going to try to sell it or anything. Alright, so I'm going to throw Pac-Man in here to my library. There he is. Click and drag him out. Now actually I'm going to have him be on the content layer. So click on content and then bring him out. He's huge, so I hit Q, shrink him down. Now the one thing to be aware of is I don't have like rotation set, so he's just going to be moving around like this. Like when he goes left, he's never, like, he's not going to look down when he's moving down. He's not going to look left when he's going left. Just he's going to look exactly like how he looks, and there's real no rotation involved. So, you know, be aware of that. Another thing to pay attention to is this box around him, because that's going to be his hit area. If you have a bunch of extra space in here, that blue box is going to be bigger, and that means his hit box is going to be bigger, and so he's going to hit things when it doesn't look like he hits things, which obviously you don't want. All right, I'm going to convert this to a movie clip too. So F8, call it Pac-Man. And then I will give him an instance name as well. I'll just call him Pac. And then the last thing I need to do is grab something that he can interact with. So I'm just going to grab that, I don't know, I guess it's Pac-Man Bullet or something. I don't know what it's called. Pac-Man Ball? Maybe bullet's the wrong word. What are the things called? You guys know what they're called? I don't know what they're called. These things. No, okay. I don't know. Spheres? It's giving me all 3D weird crap. Whatever, I'll just say a ball icon. There we go. That'll work, I think. I want this to be a PNG. There we go. That'll work. Call it ball. And same thing. Throw it into my library. And then throw it on here. Way too big. This thing's going to be really small. because this is going to be what I'm going to be trying to get. Now we have an issue here. We kind of have a lot of space on this. So I'm actually going to go back into Photoshop and shrink everything down because that's too much extra space. Because we got to make sure it's cropped completely to the edges or it's going to mess with our game. And this is what I'm talking about. All this extra space right here. We don't want it. It needs, because if Pac-Man hits right up here above the ball, it's going to trigger that hit effect, and we don't want that. It's going to trigger the hit event, and then he's going to, it kills the illusion that he actually touched it. So it's pretty simple. All we got to do is just crop it down. Get rid of all this extra space. There's not a whole lot we can do about this, the corners. It's just kind of how it is. Anyway, save over that. Now, a lot more snug on the ball. We can bring it over. Hit Q, bring it down. Okay, and same thing, convert that to a movie clip now. Call it ball. Give it an instance name of ball. So now we got it all set up. That's all we're going to do, like visually. The rest is going to be controlled in the code. It doesn't matter where we put these because we're going to randomize it. I guess it does kind of matter where you put Pac-Man. Wherever you want Pac-Man to start. You can put him probably in the middle, wherever. But the ball we're going to have be random. The ball is just going to be in a random spot every time the game loads. Now, I already kind of talked about this, but last quarter we had a few students just kind of ditched this whole idea about boundaries, and they had a character, trying to get this ball thing, as it were, like the ball's up here, the character's here, and then there's just a bunch of like obstacles in its way. That was kind of cool. So you had to kind of navigate through this maze to get to the ball. My game, and to be honest, that's probably a cooler thing than what my game's going to do. I probably should redesign mine, but mine's kind of dumb. It's just going to, once he gets the ball, he gets a little bigger. Once he gets it, again, he gets a little bigger and bigger and bigger until, the dumb thing about that is it gets so big that it gets to the point where you can't really do anything anymore. Like navigating through to get something, I think, is a cooler concept. And then, of course, we talked about the other ones where there's just a big movie clip. It's scrolling down and you have to dodge things as it comes down. I don't know, and that's the thing. It's kind of up to you. Think about once you see the hit detection and what can be done, then you can have an idea of, all right, this is how I want my game to be.
So if mine is evading multiple things, does that work?
Yeah.
But they all have to be on the screen at one time? Or?
Mm-hmm. Yep.
They can't just be like falling from the top or anything like that?
If you have them fall from the top, you can do that. But to have it like randomly happen forever, I'm worthless on that one. I don't think I'd be able to really help you do that. I could try to help you. Like we could sit down and try to figure it out. We might be able to, but it would be randomly. You basically have to like randomly place a movie clip up here and then have it go down, and then randomly place it again, have it go down, and so forth. Or you could have it, you could tween it, right? It'd be the same every time. Like you'd have something down here and you'd tween it down. You'd have something up here, you'd tween it down. And then you could maybe have like levels where you have 4 or 5 drop down, you dodge them, then it goes to the next level. Then you have 5 or 6 that maybe go faster, and then it goes to the next level, and so forth.
And all those have to be individually.
Mm-hmm. Yeah. To be honest, that would be easier, like tweening them all individually than doing it with code. But you know, that's kind of up to you what you want to do there.
So that means that my borders on the bottom and the top wouldn't, or would they, like say my spikes, would they just be barely showing to where I'd still die if I went lower? Or?
I don't know. It depends on what you want to do.
Okay.
Like if it's just trying to catch things that are falling or avoid them that are falling, then you really don't need spikes. Unless in the case where like you're trying to catch them, and if you don't catch them and they hit the spikes, then game over. Then yeah, you would need some sort of spikes down here. So if the ball's falling and it hits that spike, game over. It all just kind of depends on how your game's going to work. Oh, and I forgot one more thing. I need a score counter. So as I touch the ball thing here, is it there? I think it went away. So as I touch the ball, the score counter goes up. So I need to create a new text box, and it's going to be a dynamic text box. It's dynamic because it's going to be changing. And I can put a 0 in there. So that's what it's going to start out with. Put it wherever I want. I don't want it to interfere too much into the game. And sure. That looks like an amazing font. Now remember, this is a font that I'm using that probably isn't on everybody's computer, so I am going to want to embed that font. So I'm going to click embed, and all I'm going to do is embed numerals. So that's it. It's a score. It's not going to be using it's not going to be using A, B, C, D or any exclamation points or anything. It's just going to be using numbers. So I'm going to embed the numerals of the Mangle font. Okay, and I'm going to give that text box an instance name of score. And that's all depends. Your game may need a score or may not. If you're just avoiding things and trying to get somewhere, it probably doesn't need a score. But in this case, where every time I do something, yeah, I want points to be added to that. It's all up to you. And I don't really want it to be red. I'll keep it yellow with Pac-Man. Oh yeah. Also, in case, this is kind of cool too. If I want this to be the exact color of Pac-Man, I can click on the color, gives me the eye drop. I just go off onto the stage and click the color of Pac-Man. And now they're the exact same color. So you can pull colors off of the stage, which is pretty slick.
Did you convert the Pac-Man into a movie clip?
I did. Everything is a movie clip on here except for the text box. So Pac-Man's a movie clip, the ball's a movie clip, all of these borders are movie clips, and then the dynamic text box. Now I want the score to be a little bit smaller here. Make sure you're saving as we're going along. You don't want to lose all this. So again, I would recommend that you just kind of do this with me, get the concepts down, and I'll give you probably another week or two for this. So you can then, once you get this to work, then you can kind of go, okay, cool, I understand what this is doing. Now I can tweak it and kind of make it do what I want it to do. That's kind of up to you if you want to go that route. Or if you're like, you know what, I think I'm going to get this. I'm just going to kind of start on my idea now. That's fine. Because really all we need to do now is just code out all the hit detection and make sure Pac-Man moves according to what the accelerometer does. And then every time he gets the ball, we add 1 to this score counter. So I'm going to start coding it now unless any of you are yelling no. Okay. F9. F9 or window actions. Oops. Just got real, people. I took off my jacket. Okay, here we go. So we got to import. Oop, that's way too small. We got to import a bunch of stuff like we did last week. We got to import some flash sensors. The first one we're importing is the accelerometer sensor. So this is a built-in class. This is what they're called. These are classes that have already been built by Adobe that have all the code and everything necessary to be able to access the accelerometer on your device. Be very grateful you're not the one who had to make that. That would have been intense. Okay, the other thing we need is the events, accelerometer event. Okay, so this is the class that allows us to access the accelerometer, and this is the class that's going to let us basically detect when the accelerometer data changes. So as we tilt the phone and move the phone around, the accelerometer is going to be feeding out new data, and we need to be able to detect when the data changes and then be able to grab that data and do something with it. Okay, and then we have the other events that we used last week, like go to and stop and all that kind of stuff. So we need to think through what's going to happen. Okay, I'm going to do all the stuff first that we've already done. So last week we had music playing and such. I want to do that. So I have gameplay music that's going to be happening, which is right here, the game music. Okay, that's going to be playing as I'm moving around trying to grab the ball. So just like we did before, we need to export this for ActionScript so we can access it and play it. So right click, Properties, ActionScript, Export, hit OK. If OK doesn't show up, I guess you can just hit Enter and that works too. Okay, definition for this class, blah, 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 that's fine. It's going to be generated. That's fine. We hit OK. Now we have the linkage of game music. That's what it's called. That's what I need to use. So this is just a review of last week. So I'm going to set up a new variable. It's going to be a sound variable. Okay, remember this is referencing the game or the music inside the library, so this game music needs to be exactly the same as what it says here in the linkage. This is a variable I just make up. This can be anything. This needs to be whatever the linkage is inside of the library. Okay, then we set up that variable that's the channel. Then we play it out. So exactly what we did last week, but for the game screen. Then you can see that it automatically imported this stuff for me, all the sound stuff that we need. So I can test it. Right, Command Enter, Control Enter, just to make sure that it plays. Perfect. Go to the game screen and the music plays. Hallelujah. That's what I want. Turn that down. Now the reason I put this in a channel is because we need to be able to stop this. So when we play it and then we go to the dead screen or the welcome screen or whatever, we got to be able to stop this. Now the sound effect when I get the ball, I called it get square because I had a square last time, but it sounds like this. Okay, so every time Pac-Man gets that ball, it's going to do that sound effect. Now, this is so short, I don't need to tell it to play and then stop. It's just a sound effect. So all I have to do is just say play and that's it. I don't really ever have to tell it to stop. So I don't need to really set up a channel for this. All I need to do is say, hey, here's this new sound, play it when Pac-Man hits the ball. So, but I do need to set it up first, and that's what I'm going to do now. Okay, so I'm going to call it variable ball. No, I'm not going to call it ball. That's another thing you need to be really careful about. I'm going to put this in comments here. Variable names and instance names should never be the same. Here, let me put that down here. This is probably one of the most common issues that hose students really bad in this project. and it's really hard to find. It's a mistake where you get these weird errors that don't really make sense, and then you figure out, oh crap, your variable name is the exact same name as your instance name, and that's why it's not working. So if I were to say, you know, ball, well, now I have a variable name ball, and then I also have an instance name of ball, because over here I called this ball. That will conflict, and that'll give you errors, and they're really hard to troubleshoot. So right now you just got to kind of get creative with your naming conventions. Just, you know, again, variable names and instance names should never be the same, because if they are, you're going to get errors and it's not going to work. So I'm going to call this ball sound. Okay, and I'm going to give it a type of sound. And I'm going to set it equal to the linkage that doesn't exist yet. So this is it. So I'm going to export it for ActionScript. Okay, it's get square. So new get square. And again, all I want it to do is play. I'm not going to tell it to stop because it's so short, so I'm not going to set up a channel. But now I can call ball sound and tell it to play when I need it to. And really, if I was doing this for like real, I would change this to get ball, because get square just doesn't really make a whole lot of sense. Like I said, before, instead of it having this ball, it was actually a little square that I drew. So that's where the square is coming from. Okay, and I got to do the same thing with the like I died sound effect. The die sound is what I called it. Okay, a little explosion. So I got to set that up too. So export that for ActionScript, hit OK. It's called die sound. So I'm going to set that up as well. So variable, I called it get dead sound equals new die sound. Yay! Reconnection successful. I still haven't checked to see if that screws up the recording. I don't know. Am I broadcasting here? Can you guys see my screen?
No. Yeah.
It came back?
Yes.
That's good. And I just lost my taskbar. Okay, there it is. Jeez. Technology's blowing up today. Again, I would recommend, highly recommend, you comment the heck out of this. Okay, I'm not going to comment everything I type, but if you want to be able to remember this, and you're going to need to remember this because you're going to have to go back and edit the code to do what you want it to do, you need to understand what every line is doing. So I would say something like loading the sound, die sound from the library. Storing it inside of get dead variable. I should probably say from the linkage in the library. And So again, we'd use the channels because this is music. This is like 2 or 3 minutes long. We want to stop it at a certain point in time. These sound effects are like 1 second, 2 second long, so we don't need to set up channels for these. They play and they're done. The music, it keeps going, so we need to be able to stop it, so that's why we put it in a channel. The ball sound and the get dead sound, no, they just play and they're over, so we never have to tell them to cut off early. All right, so now that we have the sound set up, we need to tell Pac-Man to follow the accelerometer and do whatever the accelerometer does. So we need to set that up. So I'm going to set up another variable, call it ACC for accelerometer. Okay, it's the variable type of accelerometer. Let's create a new variable and giving it the type of an accelerometer. So this is a variable that's going to hold a new accelerometer. So this is how you make that connection. This is how you tell the program, hey, you are going to be paying attention to the accelerometer here. Whatever the accelerometer does, you need to translate that back into movement for what Pac-Man does. Set up a couple other variables. Okay, this is an integer. So in other words, just a number. This is going to be the x coordinate of the character and the y coordinate of the character. And we're just setting them equal to 0 to just start them out because they will be changing. Okay, and also I need a variable of score because that's how I'm going to update this. Oh. I gotta see what I have here. Yeah. Remember, I already am doing what I said not to do. What did I do that's bad? See if you guys are paying attention. Yeah, exactly. So my instance name is score, so I can't have this variable of score. So I'm going to keep score in here. I'm going to come over here and I'm going to rename this to points, PTS. Not TS, PTS. Okay, so yeah, PTS, and then yeah, because that would have messed me up later. I don't want that. So variable score, can't have instance names and variables the same. So I'm basically just setting up these variables that I'm going to be using later, setting them all equal to 0. Later on, they will be manipulated and messed with. The tx and ty variables, those are going to be the x coordinate and the y coordinate of the accelerometer as it's moving. And we'll be using that here in a minute. And again, it doesn't have to be tx, doesn't have to be ty, it can be whatever you want it to be. Okay, now the accelerometer data is stored inside of ACC. We need to now pay attention to the accelerometer. Whenever the accelerometer does something, we need to grab that data and then translate it into the position of Pac-Man. So acc.addEventListener. Okay, the event that we're listening for is an accelerometer event. Update. In other words, when the phone is tilted and the accelerometer detects that tilt, it will then fire out new information, and we're listening for that now. So whenever the accelerometer event of update, in other words, whenever it changes, we're going to be listening for that now. And when that happens, I'm going to run a function called update. So this is just like the event listeners for the buttons that we had, except for instead of we're listening for a click, we're listening for when the accelerometer changes. And we can do that because we saved the accelerometer inside of ACC. So we're listening to the accelerometer. We're listening for an update event, which is just whenever it changes. Whenever the accelerometer changes, we're going to run a function called update. This function could be ran many, many, many times a second and will be ran many, many times a second. This is why computers are awesome, because they're fast. They can do things hundreds of times a second, thousands of times a second. Okay, now I need to define what that is. So when the accelerometer updates, I run a function called update. Well, where is that? It's right here, function update. And the event that it's taking, the event that it's dealing with is that accelerometer update, or the accelerometer event. Now we're going to store the data the accelerometer gives to us back into tx and ty. So I'm going to say tx is going to be equal to the event e, right here, the event that's going on, the event of it being updated, acceleration x. And ty is going to be equal to the event acceleration y. Acceleration x and acceleration y is just built-in command inside of Flash that's used for the accelerometer. If you're tilted, if your phone is tilted really, big time, I don't know how to say it, like tilted way upside down, then the acceleration is going to be very quick. If you're barely tilted, the accelerometer is barely going to accelerate, and then you'll know that it's not tilted very much and it won't move very fast. You can, and you're going to have to. Well, what do you mean by manipulate it?
Can you dampen it also?
You can.
So if you tilt your phone, it doesn't respond on the one.
Yes, and we're going to have to, because right now the data that comes back is so small. Even if you're tilted like this, your character's barely going to move. And so you have to play with. So I've already done it, but well, I was just going to show you. Nah, but we don't get to it yet. So you have to times this by 100 to really get it to have kind of natural motion. Or at least that's been kind of the magical number that I found. Because I think this is returning like decimal numbers, like 0.03, 0.21, blah, blah, blah. And so when you times that by 100, now it actually gives you more natural motion, and it moves kind of like how you would expect it to. You can make it more or less, yeah. You could times it by 10 and then it moves slower, or you could times it by 100 and you're going to be killing your guy very easily because he's going to be jumping all over the page as you barely move it.
And then I'm assuming we don't have to be the same either, so you can move
Nope.
the Y more than X.
Definitely. And this is where testing is going to come, right? And you'll play around with it and get an idea of what values work. Okay, so now that we've set up the accelerometer data and we're capturing it, it still isn't going to do anything. This is all happening in the background. So if I were to run this, Pac-Man still isn't going to move because, yeah, I'm capturing all the, well, I guess I'll just show you. So we'll save it and run it. Turn it down here. Okay, so we hit start. I'm moving the phone around. He's not moving. Now the accelerometer data is being captured right now. Like it knows that it's being tilted. It knows that it's getting moved around and such, but I haven't said, hey, use that data and attach it to Pac-Man's location. And that's what we're going to do next. All right, so I'm going to add an event listener to this, which is the animation, or the stage, whatever you want to say. The stage, the frame, scene one, whatever, that's this. Okay, and the event that I'm going to be listening for is enter frame. And when it happens, I'm going to run a function called loop. This is the backbone of most game development. Any video game you play, there are hundreds, maybe even thousands of loops running multiple times a second. You know, there's a loop that's detecting, are you on a mountain, or are you falling, or are you in water? If you're in water, okay, start the swim animation. If you are not touching the ground, then fall. I don't know, there's just hundreds of loops running to check to see if the character is doing something. So this is the loop here that's going to be running every time you enter a frame, which is, well, this 24 times a second, because it's 24 frames per second. So every time we enter a frame, it's going to run loop. And that's 24 times a second, because this is 24 frames per second. So I could say something like, this event happens, 24 times per second and runs loop. I don't know. My comments aren't that amazing. But this is the game loop. This is the loop that happens over and over again to say, hey, have you touched the ball yet? Have you touched the ball yet? Have you touched the ball yet? Have you touched the spikes yet? Have you touched the spikes yet? It's asking that 24 times a second. So this loop gets ran multiple times, and this also is the loop that's going to help us make it look like he's moving. Okay, so this loop is controlling all the movement and all the hit detection because it happens so many times per second. So now we got to write it out. Function loop. Okay, and it's just an event. Now this is going to be the function where we attach the movement to Pac-Man. So I come back here, I call them Pac. Very important that you remember that. Whatever you called your character. And I'm going to say, all right, Pac.x is going to be equal to tx. Now again, I've played around with the values a little bit. I found that if you times that by 0.3, moves pretty naturally. Oh, and it's not equals though. It has to be minus equals. Okay, and then pac.y plus equals ty times 0.03. So 24 times a second, it's going to be changing the x coordinate and the y coordinate of pack to whatever the accelerometer tells us, times 0.3.
What's the, why is it plus and minus?
Awesome question. So if I were to say pack.x is equal to tx, the problem with that is every time this, it's just going to set it back to what it was. So maybe it tells me it's 0.3, and then it tells me 0.2, and I'm not really going to get any smooth motion. It's not going to add upon itself. So the best way to explain this, I think, is if I say x equals 1, or x equals 1, it's always going to be equal 1 no matter what. If it changes, it'll go back to 1. If it changes, it'll go back to 1. Now, if I say x plus 1, or plus equals 1, that means it's going to take whatever it was before and add 1 to it. So as this changes, x, if I go, so if I said like x equals 3, let's get rid of this. And then I say, okay, and then later in the code I have x plus equals 2. Well, x is now going to be 5. Because x was 3, and it took whatever x was before, and it added 2 to it. So this is how you can start to kind of count in programming.
You have the x value set to minus equals 1 always drop.
Yep, so if I had x equals 3 and then I had x minus equals, well now x is going to be 1. The next time it runs, it's going to be negative 1. Do I know how to count? Yeah, I know how to count.
Does that not make it like move one direction all the time?
It does. Like if you have the negative equals and the plus equals is just how it needs to be set up to where when you're tilting down, he goes this way. And when you're tilting up, he goes this way. And when you tilt this way, he goes that way. If you were to, you can play with this and you'll see. But this is just the direction that it needs to be to get him to move where you would expect him to move. But the plus and equals, the plus equals and the minus equals are used in loops, so you can take a value and continuously subtract from it, or take a value and continuously add to it, instead of it just being equal to the same thing over and over and over again. And that's how you get that smooth motion, because his x, the x coordinate is always getting subtracted from, so it'll always just kind of slowly move where it needs to go. And the same with the y, it's getting added to it or subtracted to it, depends on what the value from the accelerometer is, and that moves it smoothly across the screen because the x and y coordinate are being changed 24 times a second.
Does the accelerometer do not negative coordinate or negative?
I think it does. I never really checked to see what's coming off the accelerometer. Trying to think if you can you log?
That would make more sense. Is that like changing the value of now?
Let's run it and take a look. Okay, so I don't know how you log things in ActionScript. Let's see. Trace. Okay, maybe trace is it. So I could say trace tx. Let's see if that works. Okay, so he's moving according to the phone right now. Crap, where's the output? Usually window output, maybe. There it was. Okay. There's the output, but this isn't. That's not giving me what I thought it would. Let's try that again. That's really weird. It may not be able to be traced. I would thought I would be able to see the accelerometer data right here, but it's not doing anything, which is kind of weird.
It kind of does on the right side where the sliders are.
Yeah, that shows you the angle, I think.
Or give like a G number.
Did it?
Yeah. On the side.
Well, I know the tracing didn't work, so that may all be set to the emulator.
Like when you remove the thumb, you get like that G number next to the sliders.
Mm-hmm.
So I think when you moved it one way or the other, it did like a negative.
Yeah, I guess, yeah, you're probably right. That probably is what it's feeding to it. Because the G is gravity, right? So I mean there it's a positive, well, but the X value is what we care about right now. So it looks like the X value is, I don't know, always given a degree. I don't know, man. Kind of wish I did. On that one, I'm not sure. But the point is, it's working. Now, I know some people last quarter wanted, you know, if you're dodging stuff coming at you, you don't want to be able to move up and down, right? You only want to be able to move right, left and right, like this, right? So it all just kind of depends. If you only want the right, then if you only want left and right, then you keep that and get rid of that. It all just depends on what you're doing with the game. But the main thing I wanted to pay attention to is, so you kind of get it flat. You want to get it flat first. You hit start. Now the Z value is what moves left and right, and then just clicking and dragging this up and down is what moves up and down.
So when you hit start on a game, does it zero the Z for whatever position your phone is in?
Yep. Well, I don't know if it's going to calibrate it. Like if you had your phone tilted and you hit start, your guy would just go flying off the screen. So yeah, you got to make sure it's like flat. So no, it doesn't like calibrate like, okay, where it's at now is 0. It doesn't do that. Like you got to make sure your phone is flat as possible. You know, I know I got to play with this. Because I know last quarter there was an easier view to play this on. And I can't remember. A student figured it out. So I think if we go here and we say flat. Come back. Oh yeah, this is easier. So this is kind of like a bird's eye view. Yeah, this is actually way better. So this is like as if you were looking at it, right? So I'm clicking and I can tilt it. So this is the way you're going to want to do it. You hit the little cog icon and do flat. Camera view is flat. And this is going to make it a lot easier. Yeah, this is way easier actually. So if you were playing it, you know, this is exactly as if you were looking at the phone from a bird's eye view. So anyways, yeah, makes it a lot easier. That's cool. So make sure you hit the cog and go flat. Okay, so it's working, yay, it's moving, but you can see we were running into the spikes, we were hitting all kinds of stuff, and it didn't care. So we need to set all that up. And this is all going to be in the loop function because we need to be checking for that hit detection 24 times a second. Yeah, so if we have an if statement, if statements in all the languages I've used. Well, not all of them. Most of them you have an if statement and then you have the condition inside of parentheses. So if something happens, do something. That's all an if statement is. So to do hit tests in Flash is pretty dang easy, and I like it. So if pack dot hit test object top, and that's it. So that's how you say if Pac-Man hit the top, Spike, do something. So I called it top. That's the instance name, and then Pac-Man is Pac. So it has this built-in function called hit test object. So 24 times a second, it's checking to see if Pac-Man hit the top. But we have a bunch of other stuff we're checking for. Or, two vertical lines means or, and that's the key right above the enter key. You hit shift slash, gives you that vertical. Or pack dot hit test object right side. Or pack dot hit test object. And I'm going to go down to the next line here. Left side. For, and you hopefully can kind of see where I'm going with this. Bottom. So you just put in all of the conditions you're looking for. So for me, if he hits the top spike, the left spike, the right spike, or the bottom spike, he died. In yours, it may be if your character hits an enemy, he dies. Or if a character, I don't know, whatever. But this is how you do hit detection. It's pretty dang easy. You just create two movie clips, and then you use hit test object. So if Pac-Man hits the top, or if Pac-Man hits the right side, or if Pac-Man hits the left side, or if Pac-Man hits the bottom, he croaked. And we need to do whatever's inside of these curly brackets. Okay, so I got to think about what do I do if he hits one of the spikes? Well, he died, so I need to go to and stop on the end screen. I need to play the dead music, a little blow up sound effect. If I scroll up here, I called it get dead. So get dead dot play.
Top and left side more, is that what you, the instance names of the spikes?
Yep, instant names of the spikes. LS, RS, bot, top. Now I gotta double check that though, because I did some weird crap before. Yep, RS, LS, top, oops, top, and bot. Yep. Okay, and I need to stop the game music. It's a game channel. Stop. So I go to the end screen, I play the blow up music, blow up sound effect, whatever, and then I stop the game music because I'm going to the game end screen. And that's it. That's what I want for if he hits the spikes. So, I mean, when you start thinking this game through step by step, it's not too bad, really. This kind of stuff isn't too bad. It's like, all right, you just got to keep questioning yourself, like, what do I want to happen when this happens? Well, code it out. So now we can test it. Going to be flat. All right. Worked. Now, you're going to get this error a lot. This is saying cannot access a property of a null object reference. What this is saying is basically now that I'm on the dead screen, I can no longer access the stuff that was on the game frame. And that's fine. You just hit dismiss and that won't show up on your phone. Oh man, Pac-Man, you can do it. Woo! And then boom, he hits it and he dies. 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 So you definitely want to test all of the different things that you're detecting in the hit tech. So yeah, he's dying on all of them. Top, left, right, and bottom. It's working the way it should. So in your case, it's going to be your if, the instance name of your guy, hit test object. If you're doing like enemy stuff, the instance names of the enemies. Or we also need to do good hit detection. This is the bad hit detection. This is the die hit detection. But we also need to do the good one. Like if he touches the ball, what are we going to do? So this is just the dead stuff. Like, okay, you died. Do this.
Different symbols have the same instances?
No. They all need to be different. It's probably another thing I should put here. Variable names and instance names should never be the same. Well, I guess I kind of did. But no, you can't have two of the same instance names. They all have to be different. You'll get all kinds of weird errors if you do that as well. This space I have here, it's not necessary. Oops. I just put it in there for readability, but there are two parentheses here because this parenthesis closes out bot and this parenthesis closes out. You can see it kind of highlights it, this one, the opening one over here, the condition parenthesis. Brackets does this as well, but it's kind of cool that it does this, that you can click on the bracket and it will then highlight the other one that matches it. That's very helpful to figure out, okay, what bracket is doing what. Like which bracket matches up with the other bracket. Like this one, I can click on this one, it highlights that one. So very quickly I can see what the pairs are. I know we've talked about this too. Careful with your tabbing. If you tab over correctly, it's just real easy to find what matches up with what. If you have an if statement, the closing bracket should always be directly under it. If you have a function, the closing bracket for the function should be directly under it. And if you're tabbing everything over correctly, they'll line up the way they should. All right, we'll do the last hit detection with the ball, and then we'll take a break because it's getting crazy in here. It does. Over here, you can write separate classes and embed them right here.
So if I gave different like enemy objects in class, could I do a hit detection for one of the classes?
You could try. I've never done it, but I'm not really that experienced with classes and such with Flash, but go for it and try. If it doesn't work, I can attempt to help. All right, so if pack hit test object ball, right, that's what I called it, I think. Can't remember, already forgot. Yep, ball, called it ball. That's really all we're searching for. There's nothing else. I don't have to say or anything like that. It's just if Pac-Man hits the ball, I'm going to change the height of Pac-Man. This is where the plus equals comes in again. So I'm going to take the height of Pac-Man, whatever it is currently, and add 10 to it. I'm going to take the width of whatever it is currently and add 10 to it. So this is how I can just make him bigger and bigger and bigger again with this plus equals. Okay, I also have the sound effect right here, the ball sound. So I'm going to play that as well. Okay, and I've created a variable that's keeping track of the score up here called score. So I set it equal to 0. So I can say score plus plus. Oops, plus plus. What that does is it's the same as saying score plus equals 1. Same thing. It's just shorthand. So it takes whatever score is and it adds 1 to it. So again, this is how you can count in programming. Take score. If score was 3, it's just going to add 1 to it. So now it's 4. Next time you hit the ball, it takes 4 and it adds 1 to it. Then it takes 5 and adds 1 to it, and so forth. So the plus plus is just a shorthand way of saying score plus equals 1. Okay, well now I need to update my game to reflect that, and I do that with this dynamic text box. So there's a property called text. So I can say PTS, which is the instance name of that dynamic text field, is the text of it is going to be equal to whatever score is. So I touch the ball, it adds 1 to my score, and then I set the text of points equal to whatever score is. And this, I don't know, has been finicky in the past. Sometimes it doesn't work exactly the way I want it to. So we'll see if it works this time. Come on, baby. It worked though, and that was pretty awesome. So what was the, I guess,
Just randomly gets bigger.
why did he get huge? What was up with that? Think through the code. Why the heck did he just, it's like he had a mushroom from Mario or something. Why did he get massively huge? Ah, I can't do it. Oh my gosh, this is so frustrating to play, even though it's better than nothing. All right. Why does he do that? Yeah, how many times is this running? Yeah, right? So he touches it. Well, the ball hasn't moved, and he's still touching it. So 24 times a second, he's growing by 10. So it's doing exactly what we told it to do. So the problem is right now, the minute he touches the ball, we need the ball to go away and go into some other random spot. And it's not. It's just sitting there. So Pac-Man's sitting there. He's still touching the ball, and it just gets really huge, and then he hits the spikes, and then he dies. So we're going to need something that tells, hey, the minute Pac-Man touches that ball, the ball needs to go somewhere else. So we don't get that effect of Pac-Man getting all huge and dying in 2 seconds. And I didn't notice, though, is the score working? I don't know if you guys noticed, because I didn't. Let's check it real quick. So the number should be going nuts, too. Okay, it is. So the number went flying up to like 14. So that's working too, so we know the points is working, so that's good. So we'll take a break, and that's what we're going to mess with next, is getting that ball to go away when he touches it and go to some other random spot. Let's be back 10:20-ish. Ready, go. Hiya.